Welcome. Today we're going to be graphing complex numbers, so go ahead and take your notes out. And remember, at any point in the video, you can pause it or rewind it if needed. Also, to jot down notes on the side. When we do our videos, I don't expect everybody to get it 100%, so jot down those notes and we can handle them in class. Okay, let's move on. Let's talk about a little bit of vocabulary. To graph a complex number, we need to look at what we call the complex plane. The complex plane is very similar to your XY coordinate system. Instead of the x-axis, we have the real number axis. Instead of the y-axis, we still have instead of the y-axis, we have the imaginary axis. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So let's go ahead and add those in. That part hasn't changed, so quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so to graph a complex number, we essentially are graphing pretty much the same way we graphed a point. Instead of an xy, we have a real and imaginary part. So let's go ahead and take a look at our first example. Our first example is -3 plus I. So the first thing we want to do is identify the real number. There's our real. Remember, in a complex number, the first number is the real number. And then we want to identify the coefficient on the imaginary number. The imaginary number in this case is simply just I. So we are looking at the coefficient in front of I, which is simply just going to be a 1. Okay, to graph it, we start with the real number. I go to my origin, and I see my real number is -3, so I'm going to go over 1, 2, 3 in the negative direction. So that part hasn't changed. Negatives are here. Positives are all the way to the right, with imaginaries are just like the y's. We've got the positives moving up and the negatives moving down. So again, I graphed my real part. That was -3. My imaginary part is +1. So on the imaginary axis, I'm going to go up 1 and move over to -3 on the real and plot my point. There's the point, -3 plus I. Okay, you can see a lot of similarities in graphing points as we knew it and graphing complex numbers. Again, it's identifying the real and imaginary, and they are essentially like your x and y. Let's take a look at another example. This example is -4 minus 2i. So again, we want to get to our real number part. So I'll abbreviate real number with the R and the imaginary with an I. So in this case, my real number is -4. On the real number line, I'm going to go again to the negative direction. And on my imaginary, it's -2. So this time I'm going to head down on the imaginary axis. There's -1, there's -2. Let's go ahead and throw those numbers in there. Trace them over, and there's our point, -4 minus 2i. Okay, we're going to have a couple special cases we want to look at in graphing complex. What happens when our imaginary number is 0? So we're actually looking at a real number. So go ahead and label him with a real. See if I can make my R a little better this time. There's our real number. And remember that our imaginary part is 0. So a real number is actually a complex number. It's just the imaginary part is 0. Okay, graphing this is the same. Move over 6 on the real axis. This time I'm going to go 0 up. I'm not going to move off it. So in this case, our point is on the real axis. Okay, our next special case is what happens when we have a purely imaginary number. Okay, so in this case I'm graphing negative 3i. He's purely imaginary, which means I simply do not have a real part. Again, that is an R. It stands for real numbers. Okay, in this case, I'm at the real part. I'm at 0. I do not move off it. The imaginary part, I just move up 3. And there it is. That is 3i. So as you can see, graphing complex numbers is very similar to graphing your normal points with your xy coordinates, except instead of x you have a real number and y you have a imaginary. Let's do a couple examples. What I'd like you to do is we're going to graph 4 minus 8i. I would like you to try to graph it on your own, so go ahead and pause the video, and when you have it graphed, go ahead and turn the video back on and I will graph it and we can check your work. We're going to do about 3 of these, so each one, remember, pause the video, you graph it, and then turn the video back on and we will check it. So let's begin. So go ahead and pause now. Okay, hopefully you've paused the video and you're turning it back on now. And here is the graph of 4 minus 8i. Since our real part is 4 and our imaginary part is 8, we're going to go over 4. 1, 2, 3, 4. Down 8. Sorry, I said 8. It's actually negative 8. Take the sign with you. So there's 1, 2, 3, 4, 5, 6, 7, 8. That's negative 8. So trace the line down, and our point should be down in the 4th quadrant. So take time, check it over, jot down any notes if you don't understand something. Moving to the next problem now. So again, remember, if I'm moving too fast, you can pause it. Here's the next one I'd like you to try. This one is negative 8i. Okay, so go ahead and pause the video and do your best attempt to graph it and turn it on when you are ready to see the answer. Okay, hopefully you've got a nice graph for me. And this one we have to remember, this is a pure imaginary number. So my real part is 0. My imaginary part is negative 8. So I simply go down to negative 8, like the previous example was negative 8 as well. Let's see, 1, 2, 3, 4, 5, 6, 7. There's our negative 8. And this time our point is directly on the line. Again, jot down any notes you might have or questions, and we'll move on to the next video, or sorry, the next example. Okay, our last example is negative 5i, and we're going to change this one up a little bit. Let's not do this one. We just did in pure imaginary, so I'm going to cross this one out, and let's just do a real number. Let's actually go with 7. Okay, so I'd like you to just graph 7 on the imaginary or the complex plane. Okay, so go ahead and shut your video off and turn it back on when you are ready to check your work. Do that now. Okay, so hopefully you're back now. Okay, in this case, this is a pure real number. That means our imaginary part is 0. So that tells me that my point is on the real axis. So real point is 7, imaginary is 0. So I'm simply going to go over 7. There's 7, and there's our point. Okay, hopefully this short video has helped you graph complex numbers. Again, jot down any notes, and remember, I don't expect you to fully understand it. If you do, that's a plus. If not, have your questions ready, and I will see you when I get back to class.